In our study, we characterized the process of limb development in vertebrates. The study of limb development is a classical model to study developmental processes, and it has been on for many decades, starting at the beginning of the past century. So from the first studies, it was proposed that limb cells, once they are induced to form the limb at the flank of the embryo, they were getting right away the instructions to make the whole proximodistal limb axis from the arm, forearm to the hand. So the basic mechanism that was thought that was operating was that these cells autonomously, once they were chosen to make the limb, they could undergo a progressive distalization from the most proximal phase to the most distal phase. And they were autonomous in making this process. So it was quite a fixed program that these cells would go stepwise, and they could never go backwards, and if they were doing the middle part, go back to do the proximal part. So in our study, what we characterize is that, different from what was thought before, the cells remain for a long time sensitive to different signals. And we have characterized that there are two main signals, one that we call the proximal signal and one that we call the distal signal. So these two signals antagonize each other, and so that the limb cells, they are interpreting continuously how much they see from the proximal and from the distal signal. They integrate this information to decide what they are going to become. The consequence of this is that you can take limb cells which are relatively late and they are making the distal part of the limb at that time, but if you expose them to proximal signals, they can be recruited or be reprogrammed to form the proximal part of the limb. So this study not only changes our view of how proximodistal limb development occurs, but it also may help us to understand malformations that are taking place in humans, which are quite frequent in the limbs. And also, they can serve as a basis to help tissue engineers to envision new strategies to produce in vitro structures. Another important aspect of the study is that this antagonism that we have discovered between these two signals is not only happening during limb development, it's also happening during the extension of the main limb axis, and it's also happening during the development of different organs like the heart and the lungs. So we think in the future, the study of this antagonism, which seems to be a quite important mechanism in development, is going to help us to understand the development of different embryonic processes and organs.